The periodic table. The periodic table is a rectangular block of elements in chemistry. We can also define it as a rectangular block showing all the elements in chemistry. Although sometimes we draw a smaller one that shows only the first 20 elements. Now, let's look at the periodic table showing the first 20 elements in chemistry. Here, as you can see, this is group 1, group 2, group 3, group 4, group 5, 6, 7, 8. So, vertical columns of elements are called groups. These are all groups. And horizontal rows are called periods. This is period 1. This is period 1, period 2. This is period 3, and so on. So, these are the first 20 elements on the periodic table. These are the first 20 elements. Hydrogen, helium, hydrogen, helium, hydrogen, helium, lithium, beryllium. As you can see, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, till you get to calcium, each one placed in its group. So, let's now see how we arrived at these groups. Groups and periods on the periodic table. A group is a vertical column of elements on the periodic table. I just said that now. Periods, a group, let me take that definition again. A group is a vertical column of elements on the periodic table. Next is periods. A period is a horizontal row of elements on the periodic table. So, the first row is period 1, the one that has hydrogen on the far left and helium. Period 1 only has 2 elements, helium on the far right, hydrogen and helium. This one on the far left and this one on the right hand corner. Then period 2, period 1, this is period 1, period 2, period 3. Each horizontal row is called a period. Period 2 and the rest have more than 2 elements. So, let's look at how the group and period of an element is determined using its shell electron configuration, using the arrangement of electrons in its atoms. So, examples. The question says, write the shell electron configuration of each of the following elements and determine the groups and determine their groups and periods. Sorry about that mistake. And determine what? Their groups and periods. So let's take the elements one by one. Sodium, magnesium, potassium, lithium, aluminum, and so on. You can pause to copy the question so that when I get to the steps, you won't have to always come back here. So let's go together. Let's take sodium first. Now, an atom of sodium has 11 electrons in its shells. And 11 electrons are arranged like this: 2 in the first, 8, and 1 in the last one. 2 in the first one, 8 in the second shell, 1 in the last shell. I'm sure you understand this. We did it before. So, to know the group of sodium, just take this last element. This last value tells you the group. So, sodium belongs to group 1. And to know the period, just count the number of values you have written. Count the number of values you have written, and you get the period. How many values have I written here? I've written 3 values. So, sodium belongs to period 3. But to determine the group, you just look at the last value in the shell configuration, which is 1 here. So, sodium is in group 1. Let's go to question 2, magnesium. Now, an atom of magnesium has 12 electrons in its shell. The arrangement is 2 in the first shell, 8 in the second shell, and 2 in the third shell. So to determine the group of magnesium, just pick out this last number, which is what? 2. So that tells you what? Magnesium belongs to group 2. Also, to determine the period, just count the number of values you have. 1, 2, 3. You have written 3 values. So magnesium is in what? Period 3. Exactly. Now, let's go to potassium. Number 3, potassium. Potassium. An atom of potassium has 19 electrons in its shell. 19 electrons. The arrangement is 2, 8, 8, 1. 2 electrons in the first shell, 8 in the second shell, 8 in the third shell, then the last one in the fourth shell. So because we have written 4 digits of values for the shell configuration, for the shell electron configuration of this atom, potassium, that tells us that it's in period 4. You understand? Because I wrote 4 numbers down to get its electron configuration. That means it's in what? Period 4. So to get the group, I just pick this. I'll check this last constant. That number is equal to 1. So potassium is in group 1. I hope that's clear. Also, lithium. Let's go to lithium. Question 4, lithium. Lithium, an atom of lithium has 3 electrons in its shells. The atomic number of lithium is 3. So its shell configuration is 2, 1, meaning 2 electrons in the first shell, 1 electron in the second shell. This one tells us that lithium is in group 1. Then, to know its period, you just count. How many values have I written? I've written 2 values. You understand? 1, 2. That tells us lithium is in period 2. Also, question 5, aluminum. The atomic number of aluminum is 13. That means an atom of aluminum has 13 electrons in its shells. So they are arranged like this: 2, 8, 3. 2 in the first shell, 2 in the first shell, 8 in the second shell, and the remaining 3 electrons in the third shell. So this means aluminum is in group 3 because 3 is the last value, and period 3 because there are 3 values in its shell configuration. Aluminum is in group 3 because 3 is the last value, and it's in period 3 because there are 3 values in its shell configuration. So group 3, period 3. So that's as simple as it gets. That's how we determine the period and group of an element on the periodic table among these first 20 elements, and in most other cases. So do this as your exercise. Answer questions 6 to 15 as your exercise. What you need to do is very simple. Just write out the shell configuration of the atom and use it to determine its period and group. So you can submit in the comment section, so I hope you check them out.